Right, good morning grade 11th, Friday 5 June. So today we're going to do the very last little bit of trick work without using a calculator, and we are going to look at proving identities. Now remember, whenever they say show or prove, you are going to split the given equation into a left-hand side and a right-hand side. You are not going to solve an equation. No term may be moved from the left-hand side to the right-hand side or the other way around. You are going to focus on the left-hand side and see if you get an answer on the right-hand side, or you can even try on the right-hand side to see if you get the same answer that you get on the left-hand. Okay, so when I look at proving these identities, I first need to remember that I have two identities. Tan theta is equal to sine theta over cos theta, or sine squared theta plus cos squared theta equals to 1. Very important to remember that I can move the cos theta over to the right hand side. So I can, instead of writing sine squared theta, I can write 1 minus cos squared theta, or instead of writing cos theta, I can write down 1 minus sine squared theta. Okay, so if I look at the examples, I'm going to focus on this is not equations, this is purely just working with the trig identities. When I look at sine theta times cos theta times tan theta, the only thing I notice that I can change to try and simplify this expression is the tan theta. And I can write tan theta as sine theta over cos theta. Okay, so that means that sine theta cos theta, all of it was over 1. I'm able to cancel out cos theta, and my answer is then sine theta times sine theta, which is sine squared theta. Right, looking at the second example. So if I look at this, what do I notice? I notice that I have a two-term expression. Okay, when I look at each term, I notice that there's a cos theta in each one of them. So I can factorize by taking out a common factor. So if I take out cos theta, I'm left with 1 minus sine squared theta. And when I look at 1 minus sine squared theta, I notice that it is an identity which I then can write as cos squared theta, and when I multiply the same base, I get cos cubed theta. You see that? So I'm taking you through all the thinking processes as well. Right, let's move on to example number 3. What will I do if they tell me to simplify sine theta over tan theta? So tan theta is, like at this stage, the one thing I'm looking out for. Now, because tan theta rewrites to sine theta over cos theta, it means that I'm going to have a fraction in a fraction. So I'm going to write the divide by as such, and then write tan theta, because tan theta is an identity. Now, what did you learn in the lower grades? That if I have a divide, I can change it to a times by tip and timesing. I see that sine theta and sine theta will cancel each other out. So my simplified answer is cos theta. If I look at example 4, I see I have 1 minus cos squared theta and I have 1 minus sine squared theta. I need to identify both to be identities. So instead of having 1 minus cos squared theta, I can write sine squared theta. Instead of having 1 minus sine squared theta, I can write cos squared theta. Once again, this is an identity. So instead of writing sine squared over cos squared, I can write tan squared theta. Okay, so example number 5. Once again, I see that I have a 2-term. And in each one of them, I have a tan squared theta. So I'm going to factorize first by taking out a common factor. So I'm going to say, hold on, I'm taking tan squared theta out. I'm then left with sine squared theta plus cos squared theta. By doing that, I notice that sine squared theta and cos squared theta is an identity, and that is equal to 1. And tan squared theta times by 1 is tan squared theta. Okay, example number 6. So I should pick up. If I have 1 minus sine squared theta, this is an identity. If I look at 1 plus tan squared theta, tan squared theta is an identity. So instead of saying 1 minus sine squared theta, I can say, hold on, I'm writing that as cos squared theta. And instead of writing tan squared theta, I have sine squared theta over cos squared theta. This is normal algebra. I am going to distribute the cos squared theta. So when I distribute the cos squared theta, I get cos squared theta plus, and that means I will have cos squared theta times sine squared theta over cos squared theta, which means those two cos squared thetas will cancel out, and I'm only left with sine squared theta. Now, what can you tell me about cos squared theta plus sine squared theta? It's the same as sine squared theta plus cos squared theta, which is an identity. Therefore, my answer is 1. Okay. So that was just a bunch of examples to how to deal with the identities using expressions. Now we're going to take these expressions and take them into equations. So why did I do that bit first? Because if I say proof, I basically say to you, you must build a wall. You must separate your left-hand side and your right-hand side. So given to you is an equation, but the moment I say proof, I'm telling you to simplify the left-hand side and then to simplify the right-hand side if you don't get the same answer, or either way. So if I look at the first one, I always tend to go with the left-hand side, majority of the time. So if I isolate the left-hand side, what do I notice? I notice that tan squared theta is an identity. So instead of writing tan squared theta, I can write sine squared theta over cos squared theta. Okay. Now what do I have now? Now I have subtraction with fractions. Now what do I do when I have subtraction with fractions? I need a LCD. So looking at my LCD, I'm going to have cos squared theta. So times by 1, I have sine squared theta minus, and sine squared theta there's over 1. So I need to times sine squared theta with cos squared theta. What do you identify or see now? At the top, I have a 2 term with a common factor. So what am I going to do with that common factor? I am going to factorize. So I'm going to take out sine squared theta, which will leave me with 1 minus cos squared theta inside. And that is over cos squared theta. Okay. So what do I want to do now? I want to get to the right-hand side. So if I look at this, 1 minus cos squared theta, I see that that is an identity. So I have sine squared theta times by sine squared theta over cos squared theta. What do I notice here? This sine squared theta over cos squared theta is an identity. So that is tan squared theta times by sine squared theta. What do you notice? The left-hand side is equal to the right-hand side. Okay. This is like learning how to ride a bicycle. The more you get used to it, the easier it's going to get. Let's look at the second example. Prove is my word. The moment I see prove, I see left-hand side and right-hand side. Okay. I'm going to do my left-hand side. And my left-hand side, what do I notice? I notice that this is a 2 term. I notice that it is subtraction with fractions. And what does that lead to? That means I need an LCD. So when I get an LCD, I will have cos squared theta. That's going to be times by 1, and that's going to be times cos squared theta. What do I notice if I have 1 minus cos squared theta? I notice that that is an identity, which means I can write it as sine squared theta over cos squared theta. Looking at that, this is an identity, and instead of writing all of that, I can write it as tan squared theta. What do I notice? I notice my left-hand side is equal to my right-hand side. Okay, example number 3. Right, so if I have tan theta plus cos theta over 1 plus sine theta equals to 1 over cos theta, and my instruction is to prove, which it is, by the way, what am I going to do? I am going to separate it into a left-hand side and a right-hand side. Okay. So if I take my left-hand side, okay, tan theta can be written as sine theta over cos theta plus cos theta over 1 plus sine theta. What do I have here? I have addition of fractions. What must I do when I add fractions? I need an LCD. So my LCD is cos theta and 1 plus sine theta. So that means at the top I will have sine theta times 1 plus sine theta, and at the bottom, on the right hand side, excuse me, I will have cos theta times cos theta, which is cos squared. Okay, so what am I going to do now? I'm going to distribute the sine theta in now. So I'm going to have sine theta plus sine squared theta, and then I have cos squared theta, and that is all over my LCD that I used. Okay, what do I notice about sine squared theta plus cos squared theta? That is an identity, so that's going to be plus 1 over cos times, well, cos 1 plus, it's cos theta, sorry for that, cos theta 1 plus sine theta. Okay, now what do you notice? Sine theta plus 1 and 1 plus sine theta, that's exactly the same thing. So I have 1 over cos theta, which means my left hand side is equal to my right hand side. Let's go through it again. I rewrote tan theta as sine theta over cos theta. That led to me adding fractions, so I need an LCD. That meant I need to distribute the sine theta in, identifying my identity, identifying that the top and the bottom bracket can cancel out. I'm left with 1 over cos theta, and left hand side equals to right hand side. Right, let's look at number 4, example number 4 that I want to do with you. So I have instruction prove. So identify your left hand side, identify your right hand side. So I've got a bracket that is squared, which means I'm going to have sine theta plus cos theta times sine theta plus cos theta. That's going to give me sine squared theta plus 2 sine theta cos theta plus 2 cos theta. So sine times sine is sine squared, sine times cos, and cos times sine is 1 plus 1 is 2, and cos times cos is, sorry for that, is cos squared theta. Now when I look at that, what do you notice? Sine theta plus cos, sine squared theta plus cos squared theta is an identity, which means they are equal to 1, and I have 1 plus 2 sine theta cos theta, and that means my left hand side equals my right hand side. Okay, last one for today. Without using a calculator, please, that will be clearly instructed to you. So now I have to think about reduction formulas, and I have to think about complementary angles or cofunctions. Okay, so if I take sine squared 70, okay, once again this instruction is prove, get the left hand side, get the right hand side. So on the left hand side, I can get 70 by saying 90 minus 20. I'm going to first leave that 20, sine squared 20 alone. Okay. I am going to leave the sine squared 40 for now because I saw a tan. So I can write sine squared 50 over cos squared 50 instead of tan squared 50. Okay. So the moment I see 90 minus, I know this is a cofunction. That means sine will have to change to cos, and in 90 minus, it means it's the first quadrant. Cos will be positive, so I'm dealing with cos 20. So cos squared 20 plus sine squared 20 will be on the top. Okay. So looking at that, what do you identify here? This is an identity at the top. Looking at the bottom, I've got 40s and 50s. I would like to have them the same. So I can rewrite 40. How did I get 40? I said 90 minus 50. Right. What do I know about 90 minus? It's a cofunction, so I can write the top as 1. At the bottom, cofunction cos will be positive, and I will work with cos of 50. And now cos of 50 can distribute into my bracket. So I'm going to distribute there. So I'm going to have 1 over cos squared 50, okay, and when I multiply in with sine squared 50 and cos squared 50, I end up with only sine squared 50. What do you notice about sine squared 50 and cos squared 50? If I add them, they are identities, so it's 1 over 1, which means my answer is 1. Therefore, my left-hand side is equal to my right-hand side. Okay. So this is a little bit more challenging than your previous work, and this is what grade 11 will focus on majority of the time. What are you going to do for homework is exercise 7.8. Originally, I said A, C, E, and G. Please add J to that as well. Have a nice day. See you on Monday.